So at the time you're watching this video, we will be halfway through week 14, cruising along toward the end of the 2020 spring semester. Today I have posted up to our left, as expected, the agenda for the day. I'm going to begin with announcements. We'll go to review. We'll do another round of mystery t-test, and we'll do our final correlation practice. Now, after today, we'll begin to look at regression, and I don't test real heavy on regression at all. So the bulk of next week's exam number 3 will be on t-tests and correlations, and frankly, that's about all we have the bandwidth for a test like that anyway, because there's quite a bit covered just for those two subject areas alone. So that's, I guess, my first announcement. The second announcement is that I went ahead and posted, and many of you have already started to turn in homework assignment number 5, which is the final one of the year, and it deals with correlations. So, of course, it's appropriate that we would do it this week. And I really get the impression that you didn't find it too difficult, and that's great. So I'm going to make sure that we get a chance to, look at some correlation practice today, which will be our final one. And I'll also, the other thing I guess I didn't put on here, but I could put at the end of this lecture as well, is how to use Excel for correlation. In fact, I'm going to go ahead and do that. I'm just going to go ahead and do that while you're here with me. Okay, correlations on Excel, because it's very easy. It's easier than chi-square, and chi-square is not that difficult. So I think that's going to wrap up the announcements for today. So just to recap, we are halfway through the 14th week of the semester. We have homework assignment number 5 due on Friday, unless there's some extenuating circumstances, and you can tell me if there are. And our test is a week away. Exam number 3. And I guess the only thing else I was going to mention was presentations. Many of you have kind of asked about, and presentations we're going to have to do, obviously. You're going to have to do them on your own, and we're not going to be doing them in front of a class as we usually do. And then the only other thing I can think of with extra credit is I'm going to be giving you opportunities after I give you a little more to work with in terms of Excel and also SPSS. So I'll talk a little bit more about that at the end of today's class. So without anything else further, we'll go ahead and start with the review portion. So now we have our review questions. It says review questions for today. I have 5 of them for you, so if you'd be so kind as to take out a blank piece of paper or scratch paper, or if you can use the side of your practice sheet. They're not really long answers, so these are very, very brief answers. You can just simply write 1 through 5 and you should be fine. So here's the first question. A t-test, okay, not t-tests, a t-test has a calculated value of negative 5.43 and a critical value of 2.60. What should happen with the null hypothesis? Okay. Number 2, a correlation coefficient is found to be negative 0.27. How would you characterize the direction, positive or negative, and strength, weak or strong, of this correlation? Number 3, a t-test has a calculated value of 1.58 and a critical value of 2.89. What can be said about the corresponding p-value for this fact pattern? Next, number 4, a correlation coefficient is found to be 0.89. What can be said about the direction and strength of this correlation? And finally, a t-test finds a calculated, I guess I could spell calculated correctly. How about that? Calculated value of 7.58 And a critical? Nah, I don't think so. Critical. There we go. I'm having spelling difficulties today. And a critical value of 3.47. How can we know whether we have statistical? Wow, I am out to lunch. There we go. Statistical significance. So let me repeat that whole thing. My goodness. A t-test finds a calculated value of 7.58 and a critical value of 3.47. How can we know whether we have statistical significance? So those are the 5 questions. They can be answered in fairly short order, very briefly, and we will come back with the answers. Hopefully you had a moment to go ahead and answer the review questions. We're back now with the answers. So I'm going to start with number 1. A t-test has a calculated value of negative 5.43 and a critical value of 2.60. What should happen with the null hypothesis? Well, let's go over to the answer. Because we use absolute values with t-tests, the calculated value of negative 5.43 is greater than the critical value of 2.60. We shall reject the null hypothesis. I included this question because I realized that a couple of students had been having there had been a number of issues with that, so I wanted to make sure we at least covered that. Hopefully that review is helpful. Let's take a look at number 2. See if we can kind of get that one front and center. Number 2, a correlation coefficient is found to be negative 0.27. How would you characterize the direction? Positive and negative, and strength, weak or strong of this correlation. A negative 0.27 is going to be, first of all, negative because it's got a negative symbol in front of it, and weak because it's closer to 0 than it is to 1. The closer we get to 1, the stronger the correlation. The further we get from 1 and the closer we get to 0, the weaker the correlation. Okay, let's take a look at the next one. Number 3, a t-test has a calculated value of 1.58 and a critical value of 2.89. What can be said about the corresponding p-value for this fact pattern? Let's move on down to number 3. Okay, here's the answer. Actually, you know what? I can even get them lined up. How about that? That's even better. Because the critical value, 2.89, is greater than the calculated value, 1.58, the p-value shall be greater than 0.05. It has to be. If the critical value is greater than the calculated, you can recall that chart I gave you. I've used it a couple times now. You know that the p-value must be greater than 0.05. Okay. Anytime we're going to accept the null hypothesis, that p-value is going to be greater than 0.05. Okay, let's take a look at number 4. Correlation coefficient is found to be 0.89. What can be said about the direction and strength of this correlation? Now let's move on down to number 4. Get them nice and lined up. A correlation coefficient of 0.89 is both positive, because it's got no negative. There's an absence of a negative symbol there, and strong. 0.89 is relatively close to 1. So that's why we would find this correlation coefficient to be both positive and strong. And now we'll look at the final question. A t-test finds a calculated value of 7.58 and a critical value of 3.47. How can we know whether we have statistical significance? And this is kind of echoing the last homework assignment. That was homework number 4 last week. Just again, I just want to hammer it home about how you know you find statistical significance. You know you find statistical significance if you reject the null hypothesis. So let's take a look at number 5's answer. Because the calculated value, 7.58, is greater than the critical value, 3.47, we shall reject the null hypothesis. Thus, we know we have found statistical significance. Don't forget, the null hypothesis for a t-test reads, there is no, what is it again? Significant difference, or you could say statistically significant difference. So if you reject that null hypothesis, then clearly what are you left with? You have found a statistically significant difference. So hopefully this review was useful to you. Okay, now we're moving past the review on to the next item, which is the mystery t-test. Let's see if you can figure this out. I'm going to give you a fact pattern. It's here on the left. And then we have the questions that are going to correspond on the right, which is also
a set of questions you have on your participation sheet for the week. Let me read the fact pattern. A social worker wants to examine whether a difference exists between the experiences of two different groups of women, African American and Asian American, at a domestic violence abuse shelter. To test this, the social worker takes samples of 40 women from each population and asks them to complete a survey rating their experience at the shelter on a scale of 1, which would be poor, to 10, which would be excellent. The sample of African American women had an average, so this would be the average on the survey, of 7.85 with a sum of squares of 4,823. The Asian American women had an average of 5.38 and a sum of squares of 2,678. Now, based on this information, let's go ahead and see, well, if we can begin to take a look at these questions. See if you can figure this out. This is also, again, on your participation sheet. A, which t-test is appropriate to solve this? Okay. B, what is the null hypothesis? How would that read? How does the null hypothesis read for this particular fact pattern? C, what is the calculated t-value? D, what is the degrees of freedom? E, what is the critical value? F, once you have the calculated and the critical t-values, what should occur with the null hypothesis? And finally, G, based on this information, what do we know about the p-value? Is it equal to or below 0.05 or greater than 0.05? Okay. I think you have all the information you need at this point to figure this out. So see if you can begin to piece this together, and then we'll be back with the answers. Okay, now I've changed up the screen so that we can do some work. I have the fact pattern to the far left, and I have the questions in the middle text box. We're going to go through these right now and see how my answers compared to yours. The first question, A, which t-test is appropriate to solve this? The correct answer is the two-sample independent t-test, and we know this because right here we're talking about two different groups of women. See this phrase right here, two different groups of women. Effectively, they're samples from two different populations. If I had just said two groups of women who suffered from domestic violence, or if I just said we're pulling two samples from a population of women who had experienced domestic violence, that would have been more like a dependent sample. But this is from the outset, two different groups of women. So again, we're making a distinction between the populations. We have two samples from each of these populations, and you can see that there is samples of 30 for each population. And we know that there was a rating, some kind of a survey handed out. And then we also see that there's differences in averages, okay, which is going to trigger a t-test anyway. But the main point here is that if you look at this language, we have two different groups and we have samples from each. That really is what cues the two-sample independent t-test. Okay, so if you were ever reading any fact pattern on a test, or I mean, clearly we're not going to be doing any more homework assignments, but in the future, if you ever were looking at a study that was looking at two distinct unrelated populations where they're making very clear distinctions between the populations, that's a two-sample independent t-test. Let's go on to B. Okay, what is the null hypothesis? Here's the one I gave. There is no significant difference between the average experience of African American and Asian American women at the domestic abuse shelter. Okay, again, the null hypothesis says no, because we're talking about t-tests, we're talking about averages, and we have two different samples, and we're basically saying that there's really no difference between the averages here. Okay. So now the next thing to figure out, I'll give it a little bit of space, is the calculated t-value. I've set up the generic formula right here. You have the equation right there. And then I went ahead and plugged in all of the numbers from the facts into the specific areas they need to go. So for example, I went ahead and said, and I designated the African American sample as the first sample, X bar 1, and the Asian American women as X bar 2. So here's what I did. You can see that first of all, in the fact pattern, the first number we come to is 30, and that's the number in each sample. That's going to be, of course, the N value. So anywhere I saw an N, we have 30. There they are. Okay, then you can see that with respect to the sample, the African American women whom I designated X bar 1, okay, they had an average of 7.85. So I went ahead and put 7.85 here. Okay, there it corresponds. And then you can see that with the Asian American women, they had an average of 5.38. I put that in its corresponding spot as well. I also, in the fact pattern, gave you the sum of squares for each group as well. The African American women had a sum of squares of 4,823. I put that here because, of course, sum of squares is this, and then the 1 below and the subscript just means which group it is. So you see X bar 1, and then we see sum of squares 1. Okay, we see the average for X bar 1, and then the corresponding sum of squares, which again, 7.85, 4,823. So everything should be lined up. I even color coded it for you. So here's X bar 1. This was the African American women. Okay, here's X bar 2. Again, this is the Asian American women, the sample of. Okay, and then of course we have over here the populations again. This is really not difficult once you've lined everything up. So we're just going to go through it now. Okay, so we'll just start again because again we're looking with a T. This is not a Pearson's R. So again, it's good to make sure we know what the distinction is. Okay, try to keep my lines straight here. Okay, just to be absolutely 100% accurate as much as I can. Oops, I'm going to go with a calculator, not calendar. All right, let's go with the calculator when it decides it wants to come up. There it is. Okay, so we're going to go ahead. Oh, I've got 2 of them today. Okay. All right, calculator. Okay, we're going to go ahead and say this. Okay, to get the numerator correct, 7.85. Okay, I didn't need my calculator or my calendar. Sorry. Okay, no, sorry about that. 7.85 minus, okay, 5.38. This will take care of our numerator. It's the easiest thing to get rid of, so it's right there. Okay, so we're going to go ahead and say knock that down. Okay, 2.47. Okay, that was pretty easy. Okay, now we got to come down and get all of our numbers calculated and processed so we can find the calculated t-score, and we'll do that momentarily. Okay, let's get some of the heavier stuff out of the way first. Okay, I'll just keep it in black for now, even though I've color coded it earlier. Okay, so let's go like this because we'll take it one step at a time for you. Always tried to make it as easy as possible. Okay. Okay, let's come back up here to this line right here. Okay, what numbers are we adding together? We're going to clear this out. We're going to go 4,823 plus 2,678. Did I get all that right? Let's move that over. Yep, I did. Okay, I'm going to go ahead and equals. Okay, so that's going to put this number here, 7,501. Okay, very good. Okay, now what we're going to do is we're going to just take a look at what we have here. This is 30 plus 30 is 60 minus 2. It's going to give us 58. And then we'll just move over here and we'll get some work done along the way. So first thing I'm going to do is just move that numerator over because it's not going to change. We're going to say 2.47. There we go. Okay. Okay. And we can just dispatch with this one right now. Let's just go ahead and do this. 7,501 divided by 58. Now it's already there, so we'll just go divided by 58. Okay, and again, we're not going to spend a ton of time on getting excited about the numbers. We're just going to go 129. That's a 2. Point, what did we say? We'll say 33, just to round up. We'll say 7 over to the 2, 33. So we'll knock that down. Okay, 33. But we still have to do what's in the parentheses here. Okay, let's just go like this. Clear 1 divided by 30. What's that number going to be? Ah, that's an easy number, isn't it? So we're going to go 0.03 plus 0.03. Okay. So here we go again. We'll go 0.03 plus 0.03, which I know what that's going to give us. Okay, that was pretty obvious. All right, so we'll just bring that over here. Okay, carry it over. 0.47. And then we're going to have, don't forget that square root, please. I'll get a cleaner 2 this time. That's better. And we're going to multiply that times 0.06. Okay. Okay, so last one. We're going to have to do any real heavy work with. Okay. Part of this is just me getting practice making all these loops with my fingers and straight lines with my fingers. This is a whole together different way of doing math. Okay, let's just go ahead and do this, you guys. Okay, 0.06 times, okay, 129.33. Okay, it's going to be 7.759. Okay, why don't we just do it this way? So we'll just, so this is what's good, what it's going to look like. Let's see, what is 7.5, we'll say 7.60. That makes more sense to me. Okay, great. Now to be absolutely accurate, we'll just go do it this way. 7.60. Take the square root. Okay. Excuse me again. Sorry about that. Okay. 2 point. Whoops. Can I make that a 4? Okay. How about that? 2.47. Once we took the square root of 7.60, what do we got? Okay, 2.76. 2.76. I can see where this is headed. Okay, so here we are. I'm going to be absolutely accurate with you. 2.47. Okay, it's the numerator, divided by 2.76. I can see where this is at. Okay, that's what I thought. Okay, so we're going to go with the t value. Once all is said and done, the t, in fact, let's be very clear, t calculated. Wow, how did I get an a that small? Okay, t calculated is going to give us 0.89. Okay, I'll go ahead and bring that up here. So we'll also make that red to make it absolutely clear to everybody. Okay, we're going to go with the t. Okay, let's say calculated t value equals 0.89. Okay, we move down here. What are the degrees of freedom? Degrees of freedom for this particular test, the two sample independent t-test, is going to be, and if you looked in your book, I'm going to get the page for you just so you're totally clear. It's on page 97. Okay, it's going to be just what you see here. Okay, so degrees of freedom. The way the book has it is a little bit different. They just go like this. They say n. I don't think they just go like this. N minus 1, or I'm sorry, n1 plus n2 minus 2, which again from our population here, or populations here, are sample sizes. Okay, this is going to be 30 plus 30. Whoops, minus 2. That's a 30. Okay, equals 58. Okay. Okay, so when all is said and done here, okay, that's an 8. Okay, degrees of freedom are going to be, so df, we'll go red. We're going to go red here. Make it lower. df equals 58 because we did that down here. Okay, if I go to the book, and now just for reference, I want to make sure I'm absolutely clear with you. I'm on page 94. Okay, there's no 58. So what's the closest number to 58 we have on the far left-hand side for the degrees of freedom? We have 60. Okay, so I'll just use 60. It's the closest. So if I go over from 60 to three columns over, the critical value is going to be 2.00. Okay. Okay. So we're going to go with again red. Here it is. Critical t value equals 2.00. Okay, what should happen? Well, let's take a look. Here's your calculated, here's your critical. Okay, so what's bigger? Critical. So what should be done? We will accept, whoops. We're going to accept it after I turn it red. Accept the null hypothesis. Okay. And finally, if we've accepted the null hypothesis, we already know what the p-value is going to be. Okay. Because again, red. Sorry, just because it makes it easier on your eyes and mine. Okay. Because we have accepted the null hypothesis, the p-value, okay, is going to be greater than 0.05.
Okay, so now we're moving on to the final correlation practice for this class. We're going to do that with a fact pattern that I have for you on the next slide, and looks like this. A social worker is interested in learning whether a correlation exists between number of siblings and interpersonal skills. Specifically, she wonders if having more siblings tends to increase one's ability to interact with different perspectives and viewpoints during the course of one's life. To examine this more closely, she takes a random sample of 10 persons and first asks about the number of siblings they have. Next, she gives them a standardized test for social cue recognition. This gives a final score
from 1, which is poor interpersonal skills, to 20, which is high interpersonal skills. The collection of data is presented below, and just as you would expect, I have a chart here with each participant, the number of siblings each has, and the skill score, you might call it the skill score, on a range of 1 to 20, where 1 is very poor or low, and 20 is high. Then I ask the usual questions. What is the null hypothesis? What is the calculated Pearson's R value? What is the degrees of freedom? What is critical, the critical Pearson's R value? What shall occur with the null hypothesis? And based on the outcome, what will the p-value be? Now, I have provided for you in your participation sheet another set of blank columns for you to record the data and move through the process. I don't think it'll take you as long as in the past because you're getting better at this. So please go ahead and stop the video here. Go ahead and see if you can set it up and move through. Keeping in mind that I'm wondering what you found to be the null hypothesis, calculated Pearson's R value, and so on. So when we get back together in a moment, I'm going to go through what I found, and you can compare your answers. Okay, returning now to the setup for the data points for our final correlation practice. You can see what I've done here is arranged it so that the number of siblings is the x value. And you can see I've put all of the values in here, and I even reminded myself what the n is at the bottom because there are 10 pairs here. And with the y variable, the skills. So for 3 siblings, we have, the first entry, the first person had 3 siblings and showed up with a score of 10 with the skills. Okay, the second person had 2 siblings and had a skills set of 12 in terms of the final score. Okay, and you can see the remainder. So in the next slide, I'm just moving through the normal process I taught you. Okay, remember, we moved from the x to the y to the xy first. So you can see how I did that. 3 times 10, 30. 2 times 12, 24. 4 times 15, 60, 1 times 13, 13, so on and so forth. So next slide should be fairly predictable. I put in the squares, so x squared column here, we just simply went 3 times 3 is 9, 2 times 2 is 4, 4 times 4 is 16, and then over here, 10 times 10 is 100, 12 times 12 is 144, 15 times 15 is 225, and so on. So if you've arranged your columns, data points to look like this, you're probably off to a good start. And the next one is, of course, going to give us or at least the next step is going to give us the sigma totals. Okay, there they are. So when you got to the bottom of our first column, sigma x is 23. Second column, sigma x squared is 73. Okay, sigma y is 116. Sigma y squared, 1,444. And sigma xy, 287. And I, of course, move the n equals 10 down. So we'll go ahead and, as predicted, we'll go ahead and move these over to our other screen where I'll have these arranged in a way, and we'll move through the calculation. Okay, I imagine this screen is beginning to look a little more familiar. As you can see, what I've done here is I've placed all the values we calculated from the previous segment and put them up here on the left-hand side so that they're very easy to fill in. And just to the right, near the top, I put the generic equation for Pearson's R. And then right below, I went ahead and filled it in. So every place we needed to put in a value, I put that 10. Okay, because we know that for this one, n equals 10, so there's the 10. Okay, any place we saw a n, I put a 10. Okay, and sigma x, 23. Okay, right there. Let's check me out. There we are. Okay, sigma x squared, it's right there. 73. Okay, it's going to be, okay. And then sigma y, okay, it's going to be right there. Sigma y squared,
right there. And sigma xy, okay, right there. Okay, it looks like we're set, so we can move forward. I guess I can close this off too. There we go. Well, I guess I didn't do that here. All right, anyway, moving forward, make sure we put the R so we know exactly what we're doing. Okay. Hardest part about this whole thing has been to do straight lines. I promise it's been, that's been the most challenging. I gave you some pretty easier numbers this time because anything times 10 is going to just be adding a 0 to the end. So let's deal with the numerator first. Okay, 10 times 287 is going to give us 2,870. Okay. And I'll put a comma there. There we go. Minus, okay, just so we're absolutely accurate. I'll go ahead and call up the calculator. You can do this with me if you want. 23 times 116. Okay, 2,668. Okay. Perfect. Okay, don't forget that square root. I won't forget to put as straight as line as I can. Goodness gracious. That's starting to go off a little bit, wasn't it? Okay. X box. 10 times 73. Yeah. I told you what that's going to be. I'm going to add a 0 to the end, anything you multiply times 10. Okay. And 23 squared. Clear that. 23 squared, 529. These are numbers we can work with. Okay. Okay, moving on. For the y box, 10 times 1,444, we're just going to end up adding a 0 to the end of that one as well. Okay. It's going to push it on over, huh? Okay, minus 116 squared. Clear it out first, that's a good thing to do. Okay, 13,456. Okay, there you have it. Now we'll go ahead and just do a couple of brief calculations and get to where we need to be, starting with the numerator. 2,870 minus, okay, 2,668, 202. Okay, it's a pretty easy numerator for us, so give it some space there. Okay. Okay. And now we'll get our X box taken care of. 730, clear it out. 730 minus 529 can give us 201. Close off the X box. And we're getting there, aren't we, guys? Not too hard at all. Okay, next one, clear it out. 14,440 minus 13,456. Okay, 984. There we go. Okay, so go over to this. Okay, again, we don't want to forget that square root. Okay. Okay. What are we going to put under that square root? Oops. Here we go. Clear it out. 201 times 984. Okay. What we got? 784. There we go. Okay. We have that number up here already. Okay, so 197,784. Okay, it's up there too. We'll take the square root. Okay, 444 and 0.73. Let's see. Yep, there it is. Okay, so here we go. This will give us the final. .73. Okay, there you have it. 0.45. That's going to be it. Okay, I'll knock this down. It's going to be, what Pearson's R is going to be a positive 0.45. Because we know it's positive, we know it's going to be going in the upward direction. We'll just make the scatter plot here. Okay. We know it's going to be going this direction. But we also know that 0.45 is kind of not very close to 1, so it's not as straight of a line. Okay, it's probably going to look something like this. It's going to be kind of thick. It's not going to be a straight line by any means. It's not going to be a complete explosion of dots, but it's going to be kind of loose. That's what it's going to look like. So now we have all that figured out. We'll go ahead and return to our initial screen where we'll do the final calculation. Okay, and now for the final touch, I went ahead and recited the questions I started with at the fact pattern when we began this. I put that in the middle here, and I put what we know so far over here. So calculated R, 0.45, okay. And let's just go ahead and look at the question. So first question asked on the PowerPoint when I gave you the fact patterns, what is the null hypothesis? My example is there is no correlation between the number of one's siblings and one's interpersonal skills. Okay. The next question is, what's the calculated R value? We know that, 0.45. We did that with because we did math, we know we did something calculated. Degrees of freedom, okay, the formula again for correlation, n minus 2. So 10 minus 2 is going to give us a degree of freedom equals, if I can get that over there. Okay, let's try it this way. Okay, 8. Okay. And we'll go like this. Give it a color. There we go. Okay, if we know this, then we put our finger on the chart on page, what is it again, 81. I'll verify that for you just a second. I have so many different books with different charts. Sometimes I get them conflated, but I'm correct this time. It is, in fact, page 81. We put our finger on the degree of freedom. We move down until we get to the 8. Then we move across to the 0.05. And the critical value is 0.632 today. That one. So
degrees of freedom. We'll make that 8. Okay, critical value in this case is going to be, again, we're going to make it red. 0.632. What shall occur? The null hypothesis. Well, critical value is greater than the calculated, so we know what we got to do. Okay. Need to accept. Did I not get the red I wanted? Accept the null hypothesis. Because we accepted the null hypothesis, what will the p-value be? Okay, in this particular case, after I've adjusted the color of the p-value, oops, goodness gracious, p-value greater than 0.05. Okay, and that's how you do it. So I know that I had mentioned earlier that we'll take a look at how to run a correlation analysis on Excel, and we'll do that now. Okay, and for our grand finale tonight, I've taken us back to Excel, where I just opened up a new book like I showed you last time. If you needed to, you could go to File, and you could do it this way too. But nonetheless, I opened up one where we had a bunch of blank cells, and what I did was I went ahead and filled in this space, then I went up and got borders. Okay, all borders is fine. Then I wrote in siblings X, just like I did before, skills Y. So I'm really using the same fact pattern we just looked at a minute ago. Then I filled them in 3, 10, 2, 12, 4, 15. Everything is the same. Okay. Now, I know that I told you yesterday with chi-square that Excel gives you the p-value instead of the calculated value, but I got to tell you that with this particular equation, Pearson's, it's going to give us the correlation coefficient. So it won't be giving us the p-value. It will actually be giving us the Pearson's R correlation coefficient. So I think you remember the magic key I used for this, equals P. If I just say equals P, look at this. I get a menu, and the second option down is Pearson. That's right, Pearson, just like you expect. If you double-click it, it's going to give you a prompt to put in an array 1 and an array 2. Array 1 is just simply the numbers for the first variable. In this case, it's X. If I hit comma, it locks it in. So now we have the blue solid. Okay, now it says array 2. Okay, and get ready. Once I hit the return or the enter key, does that look familiar to you? It's the one we just found. We did all that math a few minutes ago. This is actually the R calculated. I have to get it lowercase r calculated. There it is. Same thing. So that's how you find it on Excel. Not too hard. Okay. So again, now you know exactly what this means because you used equations to find it. And it probably has a little more resonance with you this way. So very good. Again, we're just building up skill sets. What I'm going to start doing now is dropping fact patterns that I will invite you to use Excel for, and I'm also going to teach you how to use SPSS. That'll start tomorrow. Okay, and tomorrow for us is it's late Tuesday for me. It's going to be Wednesday by the time you hear this. Okay, have a good night, and tomorrow have a good day.